Dear students, today we shall start the new topics. Laplace transform, it was over. Now we consider the new topics. This is Fourier series. Fourier series is all the solutions are long but easy. Solutions are long but easy. Now we start Fourier series. Now what is Fourier series? Before discussing Fourier series, we have to know periodic function. So before discussing Fourier series, first you have to know periodic function. Now what is the definition of periodic function? If the value of each ordinate ft repeats itself at equal intervals in the abscissa, then ft is ft to be a periodic function. Now for example, ft equal to at t plus t at t plus twice t at t plus twice t plus twice t dot dot dot. So t plus twice t is capital T. So if we have this one, ft equal to ft plus t, t plus twice t, t plus twice t. So this is a periodic function. So here t is called period. So t is called period. So ft equal to this, ft f of t plus capital T. So t plus capital twice t, t plus capital twice t. This is called then t is called period of the function ft. So this is our periodic function. So period ft equal to this. If we express in this, then all of this equal to ft. Then this t is called period of the function ft. Now in case of sin x function, if we consider f of one example, we consider in case of f of x equal to suppose sin x. So in case of sin x, so we know f of x plus twice pi. This is f of x plus 4 pi. Then this is period is twice pi. Then this is also a sin x function whose period is twice pi. Sin x, cos x whose period is twice pi. So this is our periodic function. This is twice pi is called period of fx, of the function fx. So this is our period. This function is called periodic function, and here period is twice pi. So this is our period. Now our main discussion is Fourier series. Now we want to discuss the Fourier series. First we want to know the definition of Fourier series. Now what is Fourier series? Fourier series means a series of cosines and sines multiple of angles of sine and cosine and sine multiples, angle and multiples of the form. We have a series by cos and sine. This is called Fourier series. Now we want to write the definition of Fourier series. So now we want to discuss the definition of Fourier series. Definition of Fourier series. A series of sines and cosines. A series of sines and cosines of an angle. A series of sines and cosines of an angle and its multiples of the form a series of sines and cosines of an angle and its multiples of the form a naught by 2 a1 cos x a2 cos twice x a3 cos thrice x an cos nx plus b1 sin x plus b2 sin twice x plus b3 sin thrice x plus bn sin nx plus . If we get this series, here cos and sine, it consists cos and sine. So this is cosine and sine. This series is called a Fourier series. Now we can write in short form a naught by 2. This whole series we can write in summation notation. Summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. We can express in this way. So no need to write whole series, we can write in short form an cos nx n equal to 1. If you put n equal to 1, then a1 cos 1x we get this, n equal to 2, then a2 this 2 here, n equal to 3 a3 cos 3 we get whole series. And similarly here also n equal to 1 b1 sin 1x we get this, n equal to b2 sin 2x we get this whole series, and this series is called a Fourier series. So this is called the Fourier series. This is our Fourier series where a naught, a1, a2, a3 an b1, b2, b3, bn are constants. These are constants. So this is our definition of Fourier series. So just you have to remember or by heart this series, no problem. If this is 1, this angle is 1x. If it is 2, then 2x. If it is 3, this surface is 3, this is 3x. If it is n, then this is nx. And here also, in case of sine also same. If it is 1, then 1x. It is 2, this is 2x. We can easily by heart this series. So this series is called Fourier series. Now, before solving some problems, first you have to know some formula. Without formula, we will face some problem. Now we start some formula. So we consider some useful integrals. Before solving Fourier series, we have to know some formula. Now this useful integrals, the following integrals are useful. The following integrals are useful in Fourier series. So we consider some formula in integrals. When we shall solve Fourier series, we always use this formula. The following integrals are useful in Fourier series. Now number 1 we consider integration 0 to twice pi sine nx dx, this equal to 0. Number 2 integration 0 to twice pi cos nx dx, this equal to 0. So next number 3, integration 0 to twice pi sin square nx dx, this equal to pi we get. Next number 4, integration 0 to twice pi cos square nx dx, this also pi. So we get pi. Number 5, integration 0 to twice pi sin nx cos nx dx, this equal to 0. Number 6, 0 to twice pi, this 0 to twice pi cos nx, this is sin nx cos nx equal to 0. So cos nx, this is cos nx cos mx dx equal to 0. Number 7, 0 to twice pi, 0 to twice pi sin nx sin nx sin nx sin mx dx equal to 0. Number 8, integration 0 to twice pi sin nx sin nx. So integration 0 to twice pi sin nx, this is cos sin nx cos nx sin nx cos mx dx, this equal to 0. So this all of this 0, only this and these two are pi answer. Next number 9, we consider number 9. So integration in case of byparts formula, u v, if we differentiate this byparts formula, u v1 minus u dash v2 plus u double dash v3 minus u triple dash, this is u triple dash v4 plus dot dot dot. So if power of variable is gradually increased, so we use this formula in case of byparts formula, where v1 means, this v1 means integration v dx and v2 means integration v1 dx, v3 means integration v2 dx, and so on. And similarly u dash means the dx of u double dash means d square u dx square, this is u double dash, u triple dash means d cube u dx cube, so on. We get this our formula. Next number 10 formula, sin n pi equal to 0, and 11 number formula, cos n pi equal to minus 1 to the power n. So n, where n belongs to I, where n belongs to I, set of integers. So these are the formula. So we have to by heart this formula. Without this formula, this chapter will be difficult, and by using this formula we can easily solve the problem. So all the solutions are easy but long. So today stop here. Next class we shall solve some problems.